We're in section 5.3, and we're going to start with example 1. Find the integral from 0 to 1 of 2x minus 2x squared. So we actually did this problem in 5.2 with the limit of the Riemann sum, but we can now use the shortcut using the fundamental theorem of calculus part 2. So we can use the shortcut now. And that's FTC for short, of the fundamental theorem of calculus, part 2. Let's make a 2 there. And so what that said was that we have the integral from a to b of little f of x, and that's equal to big F of b minus big F of a. So this gives us a way to evaluate definite integrals in a much easier way than the limit of the Riemann sum. So I'm just going to write in here that f is the antiderivative. Big F is the antiderivative of little f. Okay, so let's write this out. Integral from 0 to 1, and then I have parentheses around this. That's just kind of like another thing to learn about integrals, that if you have more than one term, you should put parentheses around it there. And then we need to determine what big F is, or what the antiderivative of 2x minus 2x squared is. So that's really easy. We learned how to do this from 4.9. So the first one, we have the constant multiple rule, and then we can use like a power rule for antiderivatives for the x part. So out front, I'm going to put a 2, which is also the new exponent for x, and then I'm going to have minus 2 divided by 3, which is the new exponent for x. And then don't forget plus c in general for antiderivatives, and I'm just going to put that in there. It turns out that it's not going to be necessary, but I'm going to show that in this example. So now what the fundamental theorem of calculus part 2 says is that we evaluate big F at both b, which is 1, and a, which is 0. So putting that all together, we have f of b, or f of 1, minus f of 0. What we're going to have is 2 halves simplifies to 1, so I'm going to have 1 squared minus 2/3 times 1 cubed plus c, and then minus, you got to be careful here in general that it's subtracting the whole thing, so I'm going to put some brackets in here since I have more than one term. 0 squared minus 2/3 times 0 cubed plus c. And so then, doing this, what we get is 1 minus 2/3 plus c minus 0 minus c. So notice that the constants cancel out, and that's going to happen every time. So you don't have to write down the most general antiderivative for big F. You can just leave off the plus c, in other words. So that's just something from here on out you can do. So this just reduces to taking 1 minus 2/3, which is 1/3, and that's the exact answer we got when we did this a long way with the limit of the Riemann sum. So this is definitely much less work.